Good morning, everybody. Let's get to work. So today we are doing another section, of course, and this one's over a very interesting skill called completing the square, which is something most of the time you wouldn't call on to solve a quadratic, but sometimes you would, and it does get things in a format that is more user-friendly for other applications in the future. So particularly, I would think solving things that are conic sections, maybe. Completing the square would be a very handy skill, but that's way down the road. Nonetheless, we're going to learn it and do it anyway. So here we go. All right, number one today, let's go ahead and just try to solve some things. We have 2x to the fourth. Whoa. 2x cubed. Oh my gosh, this isn't quadratic stuff. There's a quadratic on the right, x squared, but there's all this other weird stuff. Now, it's not a quadratic. Nonetheless, when we do get to things like this, the strategy will be the same. Get it equal to 0, right? So I'm going to move this 144 thing over. And even when we have bigger things like this someday in the future, the first step will be the same. Can you factor something out of everybody? Don't forget to check for that first, okay? So is there a number or a variable that goes into all of these? 2. How about some x's? How many x's do they all have? They all got 2 x's. So I'm going to factor a 2 and an x squared out of everybody. Once we do that, what's going to be left over is something that we can handle. Now, if I take a 2 and an x squared out of this, there were 4 x's, so there's going to be 2 x's left. So there's going to be an x squared remaining. The next term, the 2x cubed, well, you took the 2 out, so it's gone. There were 3 x's, and you took 2 of them out, so there's going to be 1 left, so there's going to be a plus x. And then the very last thing, the minus 144, well, I took a 2 out of 144, so you got to figure out what 144 divided by 2 is. That's negative 72. And you took the x squared out. There was an x squared. You took it out, so there's no more x's or anything left. So this is what is remaining here. And what remains is something that we could handle right here. We can factor this thing. So I'll tell you what. Can you think of 2 numbers that multiply to be 72 at all? Thank you, 9 and 8. And one's got to be positive, one's got to be negative, correct? And what a coincidence that positive 9 plus negative 8 is positive 1, right? So we're going to do x plus 9 and x minus 8 for our factoring. Check that it worked out. That's x squared minus 8x plus 9x. That's x minus 72. We're good, okay? And we're done factoring. The whole point of factoring, again, is to see when all the factors are equal to 0. So this is a factor in front. This is times this, and this is times this. So I've 3 kind of factors here. The first one, well, let's just go set that equal to 0. 2x squared equals 0. Well, let's just divide by 2. There's no reason to have this 2 in front. If you divide both sides by 2, 0 divided by 2 is still 0. And we take a square root of both sides. That's one of the subtopics today. You get plus, don't forget to do plus or minus. You get plus or minus 0, but with 0, plus or minus doesn't really matter. So that's the one time you don't need to worry about a plus or minus. So that factor tells me x could be 0. Going down this one, x plus 9 would equal 0, but immediately that implies x equals negative 9. And over here, if x minus 8 equals 0, then that immediately implies that x must be positive 8. So there are 3 answers to this problem, which is kind of cute right there. So you're already doing bigger things right there. It just turned into something simpler that you already know how to do. All right, let's try another one. Number 2 doesn't look scary. That's not going to be so bad. It's going to be all right. All right, 121x squared equals 4. So what do you guys think? Thoughts? Strike the 4 over. Sure, that works for me. Lots of ways to do it. If you were thinking of doing something else, you may not be wrong. Okay, well, let's try to factor it. Boy, that first thing in front's a 121. Does anybody know sometimes something that's 121? Close. 11 and 11, I think, right? Yeah, 11 times 11. Yeah. So that's my bet. Let's bet that this is 11x and another 11x. Maybe. It could be 121 and 1. That's highly unlikely. What about the 4 on the end? You get a 4 and 1, right? Or 2 and 2. I'm thinking it's going to be 2's. And since it's a -4, I'm going to put 1 as positive and 1 as negative. Now, let's see if that actually works out, because I'm just guessing at things here. Or am I? 11 times 11 is 121, so I got 121x squared. Next would be -22x. Ooh, I don't want -22x. But on the very next distribution, you get a positive 22x, right? So those cancel out, and 2 times -2 is -4. So this does work out. So let's go see when they're 0. If 11x plus 2 is 0, then we'll move the 2 to the other side. Now it's 11x equals -2. And dividing by 11, one answer would be -2 11ths. This factor right here, well, if 11x minus 2 equals 0, then 11x equals 2, and this time x equals positive 2 11ths, which is just fine by me. Score. That was fine. I like that. Is there a faster way?
Yeah.
What's the faster way, anybody? Yeah, that's true. Could you just take a square root right from the get-go? Yeah, you can take a square root of both sides. Just like everything we've been doing, could you break the square root into 2 parts? Yeah, because it's 121 times x squared. If I do the square root of both of them, I can separate them out. And on this side, square root of 4 is just what, 2? Right? And that's what, 11? So 11x is plus or minus 2, so x is plus or minus 2 over 11. That's a little more elegant. That's fine too. Doesn't really freaking matter as long as you get to the answer, correct? Cool. All right, let's try 3. What the heck's that about? Write her down. Let's see what happens. Not equal to 0. That's a problem. Let's get that 2 moved over right off the bat. It was a +6 and a -2 on the right, but I'm going to move the -2 on the right over. Combine it with the +6 and just turn to this thing. Okay, they don't have anything in common. There's something I can factor out. So we're going to dive in with the normal stuff. It's got to be x times x because it's an x squared in front. So got to be x times x. Now I'm thinking of things that go into 8. I'm agreeing with 4 and 2. Positive 4, positive 2, or -4, -2? Yeah, both negative. Outstanding. Yeah, that works. -4 times -2 is positive 8. -4 plus -2 is -6. Everything's great. So the answers are, if you look at them, what makes this one 0 is when x is 4, and what makes this one 0 is when x is 2. That was easy. Nice and short on that thing. All right. And one more to go. I just threw this on there just to mess with you. See what you might think. I'm sure it scares the crap out of you. All right, look at this thing. This is not related to the unit, but I just thought it'd be fun to try this out. Does this scare you? Because of the fraction? Because of the fraction, right? How do you get rid of things on the bottom? You just, if you have a 1/3, you could multiply by 3 and get rid of the 3 on the bottom, right? If you had a 1/5, you could multiply by 5 and get rid of things on the bottom. Well, if I have a 1 over x, I can multiply everything through by x and get rid of the x on the bottom. So I'm going to multiply through everybody by x. This one times x. This one times x would make it x squared, right? And this one times x would be now 2x. So I'm multiplying everybody through by x. And why might you do that? Because right here, this x and this divide by x cancel out. I got to times x, I got to divide by x, they undo each other. So really, this equation is just 1 plus x squared equals 2x in disguise. We'll spend probably a month on that one concept right there. Like just multiply through by the bottoms and it's gone. And then you want to get it equal to 0. So I'm going to move this 2x over. I'm going to write in the normal order. I'm going to have the x squared, then the minus 2x, then the plus 1. That's the best order to do. Because now if I look at it, I can think about factoring. I think this factors into x minus 1 and another x minus 1 because -1 times -1 is 1. -1 plus -1 is -2. And since they're both identical, they're both going to have the same answer. What makes them 0? X minus 1 equals 0 implies that x equals 1. So the answer to this problem is 1. That makes sense. 1 over 1 plus 1. plus 2 is, or excuse me, plus 1 is in fact 2. So here we go. Let's do some algebra. I got a long one today because there's a lot of stuff in this section. A lot of stuff in this section. I'm going to try to boil it all down to one concept, though, for you. If I had to say there's one thing to learn from today, it's this idea of completing the square, which itself is a little bit complicated. Nonetheless, I will give you a nice fancy formula to take all the thought out of it for you. As long as you can match things and write them down, you will be fine. Per student demand and my own frustration over the online system, from now on, you will have the option of either doing homework the way you have been on Reveal online, fighting the system and turning correct answers in and getting yelled at for them because the eye's in the wrong spot or something trivial like that. If you want to keep fighting that fight, be my guest. However, you do have the option to start doing your homework on paper and turn it into the tray here in class. That is fine. If you're remote, you're welcome to do it on paper and turn it in through Google Classroom scanned. That would be fine as well. But every assignment, it's up to you which route you want to go. You can do it on paper or you can just do it online like old school. Now, since we're doing it on paper, you're going to have to know what problems are assigned from the book. I can't just give you a code, go do homework 3.5. Well, what is it? You got to go look in the book and see what the problems are. So from now on, when I post homework, it'll give you a page number and what problems to do. So if you're doing it on paper, you definitely need to write that down because you don't want to be sitting there doing all the problems. For example, here's what today's would look like. And if you are intending to do this on paper, take a minute and write this down. Homework 3.5 will be the new one. It's on page 179 of your online textbook. It's problems 1 through 17. Now, I want you to be very careful how I'm labeling things. You see that O after the 1 through 17? That stands for odd. Make sure you know that that stands for odd or write out the word odd. If I put an E after something, guess what that stands for? Even, right, yeah. Be very careful about that. You don't want to do double the problems. If I gave you the odd ones, make sure you just are only doing the odd ones. The next block, 27 through 42, I want you to do multiples of 3. So anything that 3 goes into, 27, 30, 33, 36, etc. And then on the end, it says 44 through 49. There's nothing after that, so you should do all of those. So every block of problems I give you, I'll tell you, if I don't say anything, just do them all. But if I put an O or a multiple of 3, make sure you do those right there. 3.4 is due today. Now, if you are going to keep doing this online, here's what's going to happen. I'm going to post all the problems that are available, all of them, okay? Why might I do that? Because if I start taking out problems, the numbers change. Like if I take out problem number 3, then number 4 came up and was number 3. And then you might be doing it on paper and say, what'd you get for number 4? And somebody might do it online. They're like, oh, what number? I don't have the same thing for number 4. So to keep all the numbers the same, when you open up the online assignment, it'll be just like the textbook. All the problems for the unit will be there. Do you need to do all the problems? No, you need to do numbers 1 through 17 odd, just like the people on paper need to do. So if you turn in with 50 problems not complete, is that okay? Yeah, provided you did the ones that were actually assigned. We're kind of clear on how this is going to go? Okay, so don't go online and do all the problems. Don't go to your book and do all the problems. Make sure you just do the problems that are assigned, no matter which format you're going. All right, notes. We got some notes to do today. Still in quadratic functions, and today we are doing section 3.5. It's an interesting one. Solving quadratic equations by completing the square is the title. Completing the square is usually a skill I don't teach until pre-calc, because you don't have to have it to survive things. Nonetheless, it's a good skill to have, so I'm kind of glad they're teaching it to you right now. What the heck is he talking about? Well, before we dive in with the actual lesson, I just want to do a little thought experiment with you guys. So up here, I'm going to take something, x plus 5, and I'm going to square it. Okay, don't write this down, just think about it. How would you do this? First of all, don't square them separately. Don't do that. To square something, it means you have to multiply it by itself, correct? So if you have something squared, first of all, write times itself. And then if you distribute this out, you get x squared plus, now how many, you got a 5x here, don't you? But you got another 5x, correct? How many 5x's is it? That's 2 5x's, correct? Okay, keep that in mind. 2 is a big thing. But 2 5x's would be 10x, correct? And then 5 times 5 would be 25. Are we down with that? That's nothing too complicated right there. Okay. What completing the square does is it tries to take things that look like this and turn them back into something that is a perfect square. Hence why it's called completing the square. We're going to try to take something and turn it into a square. Now, I'm going to ignore this for a minute. We would agree that this equals that. Would you concur with that? Okay. I'm going to do something weird here. I'm going to subtract 25 from both sides. So this side would be x squared plus 10x if I subtract the 25, correct? And this side would be this. Your goal for completing the square is to take something that has x squareds and x's in it and turn it into something that has a square in it and maybe some leftover stuff, okay? So does everybody kind of see where that came from a little bit? Now, I want you to look at the numbers involved here. Here, if you were given this, forget this. You don't know it started with 5. Forget that. It's not there. If you were given this, isn't 5 half of this number? This is 10, correct? So 5 is half of it, right? So guess what that goes there? 5. And what's that number squared? What's 5 squared? It's 25. That's what goes there. That leads us to this formula, and I want you to write it down because this is the big one for the day. We're going to use this over and over and over again. I'll just do it right now. I was going to do it later in the slides, but we're going to do it right now. Completing the square. That's just what this is called. In general, if you have something that looks like this, so I'm going to say x squared plus some number times x. I'm going to use b just because usually we put b's in front of our x's, right? ax squared plus bx plus c or something like that. You can turn it into this kind of thing. Complete the square is what that's called. And remember what the relationship was. This number was half of this one, correct? So what's going to go inside of here is half of this number. Now, if it's b and I don't know what it is, how do you do half of b? You just take b and divide by 2. So it's going to look like this. But then you have to subtract off this weird extra thing over here. And where this thing came from, it came from that number inside, whatever it was, 5, right? Squared. Well, the number inside here is b over 2. So you have to subtract b over 2 squared. Put a big star by that. That is what you're going to refer to a lot. I will give that to you on the test too. I will not expect you to memorize that formula right there, but I do expect you to know how to use it. And the point of it is, we're going to take anything that looks like this, turn it into something like this to solve problems, and then you're going to see how that works from there. All right, let's try this thing down here. I don't think you need to write this down. It's something that I've already harped on a lot. If you have something squared equals a number, how do you undo a square? Square root, right? Don't forget your what? Plus or minus. That's all this slide is saying. So I wouldn't even bother writing that thing down. I don't know. Let's try this one out, okay? So this is actually taught before what I just said about completing the square. So in theory, you don't know anything about completing squares when you look at this problem, but write it down anyway. And I'm just going to teach you how to do it without even any thought, okay? So here we go. No matter what problem's thrown your way today, probably the strategy is to use this formula right here. Now, this formula is for the x squared and the x part. See how it says just x squared and x? Doesn't have any number on the end of it. So you don't really care about this number. This is what I'm focused on, okay? The 4 is just going to chill. We're just going to let the 4 hang out there all day. Cool? Now, according to my formula for completing the square, what would b be? b would be -4, correct? So I can take this expression and replace it with this expression, and that is the point of it. So here we go. The thing on the right of the completing the square equation says x plus b over 2. Now, what was b? Negative 4, right? So negative 4 over 2 is what? Negative 2. So right in here, I'm just going to write x minus 2. Why not? Negative 4 divided by 2 is negative 2. And that is squared. But I'm not done, because my formula also says minus whatever that number you just figured out was, which was negative 2, correct? Squared. Now, what's negative 2 squared? Negative 2 times negative 2. 4. Good. So this is from the completing the square. This is still the underlined part right here. We just use our formula. We turn into a perfect square like this. We still have this plus 4 on the end. And we still have this equals 25. Now, look what happened to work out nicely on the left right here. What do the 4s do? They cancel out. So we don't need to worry about them anymore. Notice what's left is just something squared, correct? Something squared. I don't care what it is, it's something squared. And how do you undo a square? With a square root. So if you take a square root of both sides, on this side, the square and the square root will cancel out, correct? And you're left with whatever there was, which was x minus 2. I just took a square root, didn't I? So don't forget your plus or minus. And on this side, square root of 25 is just 5. This is why this completing the square thing works. Because if I can write this as something squared all by itself, then how do you undo it? Just take a square root. That's the point of this method right here. If you can write this as just one thing squared, then you can square root and solve it. Okay, now there's a plus or minus, so let's go down 2 different paths. Ready? If x minus 2 equals positive 5, then that's one equation to solve. And the other one is x minus 2 could be negative 5. And then you move the 2 to the other side on both equations, and on this one, you get x could be 7. And on the other one, if you add 2 over, you get x could be negative 3. And you have solved this thing without doing any kind of weird stuff, except using your formula called completing the square, which takes a little getting used to. So more examples would be really, really good. Let's try this thing out. Yes, sir. Yes, babe. Completing the square. Let's try this thing. What in the world is this? X squared minus 38x plus 361, 576. Now, these particular problems that I'm modeling right now were not designed to be solved with completing the square, but I am having you practice it because it works all the time. So I'd rather you learn one thing that works all the time than me try to teach you like 8 different strategies that sometimes work and sometimes don't. We'll just always use this thing right here. Okay, now let's start by completing the square. Don't even worry about getting it equal to 0. Don't worry about that on this particular method. Just complete the square. Completing the square is about just the x squared stuff and the x. It's not about anything else. I don't care about the numbers. I don't care about those at all. And we're going to apply our formula to it. We're going to turn x squared plus bx. In this case, b would be negative 38, correct? We're going to use that little formula, and we're going to literally turn this into that. That's all completing the square is. So according to my formula on the right, it starts off with x, and then plus b over 2. Now, here's the b, right? Negative 38. So I got to figure out what negative 38 divided by 2 is. Anybody know what that is? Negative 38 divided by 2. Get your calculator out. We need it. Negative 38 divided by 2. What's 40 divided by 2? Wouldn't 38 be 1 less 2? So it wouldn't be 20, it'd be 19. Or just type in your calculator. But b is negative 38, so b over 2 would be negative 19. So in this formula, I'm putting x minus 19. Just making sense what I'm doing? I'm just having it, right? I'm putting the formula. I hope that's pretty clear. I'm just matching the formula exactly. And I'm not done, because the formula also has this minus whatever that number was squared. So if it was negative 19, I got to figure out what negative 19 squared is. So in your calculator, put parentheses around negative 19, because you're about to square a negative. Make sure you always have parentheses around your negatives when you square them. Type in negative 19 in parentheses and then square it and tell me what that would be. It would be 361. So this, by completing the square, turns into that right there. You're not done. Don't forget there's still other stuff. There's this plus 361 we didn't do. And on this side, of course, there's equals 576. Do you see how these two numbers keep canceling out here? That's because these problems are not set up to be done by completing the square. It's supposed to be some other tricks. But don't worry about it. Completing the square works. These cancel out. So really, I just got this thing, x minus 19 squared. X minus 19 squared right here equals this thing. So how do you undo this square? Square root. We're going to take a square root of both sides. On this side, when you take the square and the square root will cancel, and you're going to have x minus 19. We just took a square root, so you need a plus or minus on some side of the equation, typically on the right side. So typically over here, we're going to have plus or minus, and I need to take the square root of this side too. So somebody figure out the square root of 576 is. 24. Oh, it's clean. Nice. All right. So plus or minus 24 right here. And then again, I have two different answers on the right, so I'm probably going to go down two different paths here. What if x minus 19 is positive 24? And what if x minus 19 is negative 24? In either equation, you'll add 19 to solve it. In this one, 24 plus 19 is 43. And over on this side, negative 24 plus 19 is negative 5. So our two answers are 43 and negative 5, all by completing the square, which is just cute. All right, let's try another one. Can't do this enough. Of course, you don't have to solve all these this way. You could move the numbers over, set equal to 0, try to factor it. All the other tricks we've already discussed still work. This is just another trick that might get you out of the weeds if you're desperate. All right. So I'm going to solve this one by completing the square. And here we go. Again, only focus on the x squared and the x's. Don't worry about the numbers. Don't worry about them. They're just going to chill for a little ride. And they are what they are. Now, this is going to work out nice and pretty again, but here we go. If I'm completing the square on this thing, first off, b would be 24, correct? And all I need to know in my equation is what that thing divided by 2 is a lot of times. So what's 24 divided by 2? 12. Okay. So that thing's going to be 12. So this is going to factor into x plus 12 squared minus whatever 12 squared is. And 12 squared is, guess what? 144. So this part turns into this. Woo! But I still have this plus 144, and I still have this 192 over here. And, of course, these cancel out. They don't always do that, but in these particular problems they're starting off with, they do. And then we have this thing squared equals 192. So that's the point of this. Get the squared thing all by itself and take a square root. If you take the square root of x plus 12 squared, then the square and the square root cancel out. And on this side, you're going to have plus or minus the square root of 192. Did anybody type that in their calculator yet? Is it pretty? Oh, dang, it's not, it's gross. Okay, well, we're not going to panic. If it's gross, it's gross. We'll just write square root of 192. Do not go give me a decimal. I don't want no decimals. I'd rather see square root of 192 than some weird decimal thing. Well, before we get too ahead of ourselves, that's a square root of something weird. Maybe I can clean it up. I wonder if there's any perfect squares that go into it. You want to check these for me? Somebody do 192 divided by 4. Does 4 go into it? I think 4 goes into it. 48. Oh, does 4 go into 48? Yeah. Okay, try this for me. Does 16 go into 192? Ah, ooh, even more. Oh, does 64 go into it? I bet it does. Okay. So I'm going to break this up into a 64 times a 3, because I want my roots as simple as possible, because that's what the curriculum expects from me. 64 times 3 is still 192. And the reason we're breaking in those two things is because the square root of 64 is pretty. It's just 8. Don't write square root of 8. You just took the square root. Square root of 64 is 8. So it's 8 square root of 3. And no matter which one I pick, the procedure would be the same. I'd subtract 12, wouldn't I? To solve it from here, just subtract 12. So if I move the 12 over to this side, it's a negative 12. And you can leave it like this if you want. You can say plus or minus the other thing still. That just means there's two answers. One answer is negative 12 plus 8 radical 3. The other answer is negative 12 minus 8 radical 3. If you want to go set up two equations, that's fine, but you're going to get the same exact particular answer. And that's just completing the square. Hassles, hassles, hassles. All right. Let's see what else we got. Okay, now this is a different kind of problem. It's the same strategy, but it's going to not work out, so things just cancel out in the middle. So sometimes they'll cancel out, sometimes they won't. Doesn't matter. The strategy will always work. Okay, so write this one down. X squared plus 18x minus 4 equals 0. This strategy is just great because sometimes things don't factor. In fact, if you look at this thing and you try to factor it from scratch, can you think of two numbers that multiply by 4 and add together in any way to be 18? I can't myself. So this is something to fall back on when you can't factor. If you can't factor something, this strategy will always work to solve it. All right, let's practice complete the square of this thing. So same thing we've been doing. Here's the first two things. I need to find a way to complete the square on them. I'm going to match my formula exactly like it looks down there, completing the square. B would be 18, fair? Okay, so I need a lot of B over 2's. 18 over 2 would be 9, right? So this is going to start factoring into x plus 9 squared minus, make sure you always have that other thing on the end, whatever that number was, 9 squared, which is 81, correct? Okay. So there's completing the square on that. I still have the rest of my work. I still have a minus 4. I still have a 0. And you see this time the things in the middle don't cancel out. That's okay. Doesn't matter if they cancel or not. Regardless of what happens, your strategy will be the same. This is the squared thing. You need to get it by itself so you can take a square root. So you agree this is negative 85? I'm going to move it to the other side and make it positive 85. That way I have this squared thing all by itself. And all the problems up till now, the squared thing naturally was just by itself. But if it's not, just move the other junk to the other side and you're good. And the point of this is to undo this square with a square root. So I do a square root of both sides. Over on the left, the whole point of it is so that square is gone, correct? Over on the right, I'm taking a square root. So don't forget your plus or minus. And I don't think the square root of 85 is pretty. So we're just going to write square root of 85. Now I see a square is something gross. I should check it. I'll give you a pass on this one. None of these perfect squares go into this. So there's nothing you can do. So you're stuck with square root of 85. And all you got to do now to get x by itself is just subtract this 9 over, making a negative 9 over here, right? So x is going to be negative 9 for moving that over. And then you either have plus the square root of 85 left over, or you had a minus square root of 85 left over. And either way, these are my two solutions. Negative 9 plus square root of 85 and negative 9 minus square root of 85. Getting the gist of it? As long as you got the formula, you're okay, right? I think so too. All right. Let's just do one more. I'm skipping some of them. I'm getting tired of doing it, but I do find people struggle with this at first. All right, so 3. Yeah, let's definitely do this one. What's different about this one? It's not just x squared. Yeah, so we're going to have to talk about how to deal with that. That sucks. This is definitely one to write down carefully. Because the formula I gave you is just for when it's 1x squared, right? So you can only use this if you have a 1x squared, but I have a 3x squared. That's unfortunate. So what we have to do is somehow temporarily get rid of this 3. Now, when you complete the square, you're always working on just these two, right? The x squareds and the x's. So here's what I'm going to do on just this part. To force it to look like that, the first thing I'm going to do is, I don't want this 3. So what I'm going to do is I'm going to factor it out of just these 2, because this is the thing I'm working on, right? This is all I care about right now for completing the square. So I want you to factor a 3 out, and I'm going to put a bracket, because there's going to be some other junk that comes inside of here, but bracket, parentheses, doesn't matter. I'm going to use a bracket. Well, I'm just going to take these 2 and take this thing out of it. So if you take a 3 out of just these 2, what will be left? An x squared, right? And 72 does go, or 72 divided by 3 is something. Anybody got that for me? Was it? 24. That makes sense. So minus 24x. Now take a step back and absorb that, because that's the important step right here. That's the thing that's different. What did you just do? You took the leading thing out of both of these, didn't you? That way, look what's left. Look what's left inside of here. That matches our formula, doesn't it? So what I'm going to do is I'm going to complete the square inside of here. So we take the 3 out, basically, so we don't have to deal with it. We'll put it back in later. Inside of here is where I'm going to complete the square. So just inside of here, b would be negative 24. Would you agree? Okay. So I'm obsessed with b's over 2's. Negative 24 divided by 2 would be negative 12, right? So the first thing it's going to say is x minus 12, and that's squared. This is why I always write a bracket in the front, because I got parentheses coming next. I don't want parentheses and parentheses, so I do bracket. You can do what you want, though. And then minus whatever that number is I just figured out, squared. Now the number was negative 12, right? Negative 12 times negative 12 is positive 144. So make sure that all made sense real quick. That's tricky when the leading thing isn't a 1. What do? The leading thing isn't a 1. You factor it out, the 2 things you care about. That's the key thing. And then proceed to complete the square. The goal of completing the square is to get this, something all by itself squared. That's the point of the formula, correct? So you took the 3 out so you could do that formula, but now you're going to put the 3 back in. So distribute the 3 back in. You take it out, use the formula, and then you put it back in. Now 3 times the squared thing, don't do anything with that. It's just 3 times that squared thing. But notice that's why I was really emphasizing those brackets and everything like that. Really emphasizing the brackets, because the 3 has to be put back in with the 144 also. So you have to figure out what 3 times 144 is when you distribute it back in, which is 432. So we put the 3 back in. We took the 3 out so we could use the formula, and then we put the 3 back in. That's how you deal with the things in front. Get it out of the way, then do the formula, and then put it back in. Now, never a bad idea to combine like terms. Let's figure out what this is. Negative 432 plus 465 is 33. So now I have this equation. And your strategy is the same regardless of what you're doing. Now you're trying to get the squared thing by itself. If you can get the squared thing all by itself, then you can just take a square root and be happy. So let's try to get this thing by itself. Let's move the 33 to the other side. It's a little closer to being by itself. But there's that awkward 3 in front still. How could we get rid of that awkward 3? Divide by 3. Yeah. So we divide both sides by 3. And that means x minus 12 squared is now negative 11, because negative 33 divided by 3 is negative 11. And finally, we got that squared thing by itself. So we're going to take a square root of both sides. The square root of this side would be x minus 12. I'm taking a square root, so I'm already thinking about that plus or minus. And over on the right side, square root of negative 11. Square root of a negative. That's an I thing. The square of 11 is not pretty. There are no perfect squares that go into 11. But it's a square root of negative 11, so you have to make it an I thing. So this is going to be a complex answer. And then the same thing as always, move the 12 over. So the final answer is x is 12 plus or minus the square root of 11i. Those 2 things solve it right there. That's a hassle. That's a hassle. We need one. I think we need to practice another one where we have a leading coefficient other than 1, because that was a pain in the butt. Let's try one more. This one. 4x squared minus 12x. Minus 27. All right. Same formula over and over and over. Problem is, it's not x squared, right? It's 4x squared. So remember, completing the square is just on these two things. So all I'm worried about is massaging these two things to make it look like that formula. So I'm going to factor a 4 out of both these two things. And that would leave me with an x squared minus 3x. I don't really care about the number on the end. That's just going to keep doing whatever it does. So I'm factoring a 4 out of the first two things. That way, the stuff that's left matches my formula exactly. B would be negative 3. That sucks, because negative 3 divided by 2 isn't pretty, is it? It's negative 3/2. But it is what it is. So inside of here, starting to do this, the B over 2 will be negative 3/2. So I got x minus 3/2 squared first, minus whatever that number is squared. Now, what's negative 3/2 squared? Negative 3/2 times negative 3/2. Negative times a negative is positive, right? 3/2 times 3/2 straight across, that's 9/4. Would you agree? Okay, so minus 9/4. And that's all in that bracket, because all that stuff in that bracket was what I was completing the square on. And you got a minus 27 equals 0. The whole reason you factored that 4 out was so you could use this formula. You just use the formula. You're done. Now put the 4 back in. So distribute the 4 back into both of these. That would give me 4 times x minus 3/2 squared. When the 4 goes to this, you have a 4, but you also have a divide by 4. What's that going to do? They're going to cancel out. You just have a minus 9 left when you do that. And then you still got this minus 27 on the end. Clean things up a little bit. Now our job is to get the square thing by itself. Negative 9 minus 27 is negative 36, but I'm going to go ahead and move that to the other side and call it positive 36. I almost got the square thing by itself. I got this 4 in front, so let's divide both sides by 4. So x minus 3/2 squared is now 9. And finally, taking the square root of both sides, take the square to the left, the square is gone. I got x minus 3/2 left. Over on the right, I'm taking the square root. Don't forget your plus or minus, and the square root of 9 is 3. And then just move the 3/2 over. So x is 3/2 plus or minus 3. Now with something like this, I would actually want you to go a little bit farther. I'd want you to figure out what 3/2 plus 3 is. In fact, we can do this real quick. Adding or subtracting 3, 3 would be the same as 6/2. Would you concur? So if you go down the plus route, 3/2 plus 6/2 would be 9/2. There's one answer. If you're going down the minus route, 3/2 minus 6/2 would be negative 3/2. So x could be negative 3/2 also. Last note, really fast. I'm going to cram in the last topic like super duper fast. We'll probably need to review it on Monday or something like that. Things that look like this, by the way. You see this thing right here? Where you got a number and then something else squared and some other junk on the stuff. This has a name. And the last thing I want you to put in your notes today is something called vertex form. Vertex form. If you can take a quadratic equation and massage it and turn it into something that looks like this. Something that looks like that. And how would you get something to look like that? You would go complete the square. You complete the square on something and do the work and make it look exactly like something like this. If you can get it to look like this, these numbers in here have a meaning. The coordinate HK, if H is the number here with the X and the K is the number off the outside, HK is the coordinate of something you know. It's the coordinate of the vertex. It tells you exactly where the vertex is for this thing. So for example, I'm going to go back to this last thing I had that was equal to 0. Guys, what would H be? H would be 3/2, right? What would K be? -36, right? So this quadratic, if I did want to go graph it, I would know that this thing has a vertex at 3/2, which is about halfway between 1 and 2, and -36, which is way down here. So I'd expect this thing's vertex to be way down there. And since the numbers in front of the x squared were positive, you know it opens up. So a rough sketch of this thing would look something like that right there. Okay. So just be aware that that's called vertex form, but you're mostly going to be using completing the square to solve problems. But if they ask you to get something in vertex form, complete the square, make it look exactly like that, and then x minus something, and then plus something else on the end. That'll be the coordinate of your vertex. Good job today, guys. Start on the new one. Don't forget, you can do it on paper or online. It's up to your discretion, but whichever option you choose, look on Google Classroom, look at what you wrote down. Only do the ones that were assigned. Don't do anything extra because that's a waste of your time and mine. All right. Good job, everybody.